Okay, let's look at conjugate of a complex number. Now, when we talk about conjugate of a complex number, we're basically talking about the opposite of that complex number. Let me explain what I mean. This is complex number, right? Complex number. Now, I told you that when you hear the word complex number, we're talking about imaginary number. So, last class, I've already explained all these things for you guys in the last class. So, when we talk about complex number, now let's consider an equation. Let's consider an equation like x squared. I just want to explain what conjugate is talking about. So we talk about the conjugate of the complex. It's very, very simple to comprehend. You just get what it's talking about. So plus 25 is equal to 0. Now, when you see an equation like this, I told you how to simplify the equation. Okay. I told you how to simplify the equation such that when you just simplify it, because of our time, we won't be doing that, such that when you just simplify it, you will arrive at something like x minus 3 squared. I told you it's the same thing because when you open your brackets, you will still get the same thing. I taught you how to simplify your bracket like this, right? Now, when you get something like this, remember, I'm going to have the heavy is equal to minus 16. I believe you remember how we got to this point. So now when you want to make x the solid of formula here, you are going to be finding the square root of both sides. That's not what I taught you. When you find the square root of both sides, this square will cancel this square. You are left with x minus 3 is equal to what? The square root, that's plus or minus the square root of what? Minus 16. And when you solve your equation now, when you solve, you are going to be arriving at coming. Yeah, since you know that this is your imaginary part, you know that when you find the square root of 16, you know you can't find the square root of minus 16. So what do? You introduce an imaginary number, and when you solve it, you're going to be getting um plus or minus what? You're going to be getting plus or minus 4i, because when you introduce an imaginary number here, you multiply this by square root of minus 1. And you know minus 1, square root of minus 1 is what? Is I. So when you introduce it, you multiply it by the square root of minus 16, which is the square root of 16 rather, which is 4. You know that this minus here will cancel the minus here and left with what? 4. So 4 times I is what? Is 4i. So when this comes here, because I'm trying to make x the subject of formula here. So when this comes here, it becomes 3 plus or minus 4i. Therefore, we will say the conjugate, because this plus or minus here is telling us that there is something like 3 plus 4i. At the same time, there is something like what? 3 minus 4i. Now, this answer here is the conjugate of this answer here. You understand? When we talk about conjugate, we're talking about what? The opposite sign of the imaginary number. This is where your imaginary number here is. This is where your imaginary number is. So what we're talking about conjugate, we're talking about the opposite of your complex number. Of your complex number. And I told you this is the general form of looking for what? A complex number, which is known as a. I told you complex number is denoted by what? By z, and you're finding it to be a plus b I, where a and b are real numbers, and I there is what? Is the imaginary number. I taught you all these things. So when we talk about conjugate, we're talking about what? We're talking about the opposite of that imaginary number. You understand? Or the opposite sign of that. So imagine here was minus, here will be plus. So if you are looking for the conjugate of a complex number, it's just simply the opposite of that number. Is that clear? So we are still going to see more examples. I just want to establish conjugates for you, and conjugates is very, very simple to understand. I believe I'm fast, but just there's somewhere I'm going to. This is not where I want to focus on. So what do you want to say?
Sorry, sir. Good evening. I attended the
This is
last class, but unfortunately, due to some things, I wasn't able to focus. So please don't clean it first. I want to use it as a
clean.
question. Just leave that part. This part where you said 3 minus 4i. I mean, sorry, 3 plus 4i. I thought after bringing x 3 from the other side, it is supposed to be in the front of or back of 4. So I don't really know. Sorry.
This is the general form of a complex number. This is the general form, just like the general form of a quadratic equation. You know that it is supposed to be
Okay.
something x squared plus something x plus what plus the constant. Is that not so? This is how complex number. This is the general form. So when writing your answer, even though your answer comes like this, 4i plus 3, you have to arrange it like this. Your a here is your 3, your b here is your 4. Do you understand? Then your I is your imaginary number. Do you get? So if you are to arrange it, it's supposed to be 3 plus 4i. That's all. This is following this pattern. You understand? So the person that has the question, do you understand? You not talk. Sorry. I muted my mic. Sorry, I muted my mic. I said the class is being recorded from henceforth. So from today, you are going to be having access to all our videos. In case you do not understand a particular class, you are going to be having the video on the YouTube, like the class we have today now, we will put on the YouTube. Some people that are saying they can't hear, please, you can hear me now. Who can hear me? Raise your hand. I muted my mic, guys. So I believe people can hear me. So as I said, from today, our class is being recorded. So in case you need a class, a video, you can just go to my YouTube page and look for it. So this particular class now will be posted. So from today, all our classes, February class, don't miss it because all of it will be recorded by the grace of God. And for the ones that we miss, I will still take my time. This week, I will be very busy this week. So by next week, when I'm a bit free, I'm going to take my time to repeat what I taught last week on the video. You understand? I'm going to do a video, or probably tomorrow. I'm very free. I think after my class tomorrow in the morning, I don't have anything doing. So tomorrow I will just set up with Salvador. So we're going to record all the classes that you have missed. So tomorrow we're going to Alright, please, I'm so sorry for the distraction. Actually, please, can you guys hear me? Which of my accounts did I just have? Please, I'm coming, please. But can you hear me? Can everybody hear me? Can everybody hear me? Alright, I'm so sorry for the distraction. Something just came on, so I just had to. So I'm so sorry for the distraction, please. Sorry. So so let's continue the class. So as I was saying, when we talk about conjugates, we're just talking about the opposite of what of that your complex number you're talking about. So please let's continue. So let's look at some examples now. Example one, they said, for example, now let's look at an example. Example, if Z, look at this example now. If Z, you have Z is equal to 2 plus 3i, then the conjugate of Z, because the opposite of conjugate is Z bar Z, there's a bar on it. So the conjugate of Z will now be what? 2 minus 3i. That's the conjugate of Z here. Now, if Z is equal to 1 minus 1 or 1 minus I, then the conjugate of Z will now be what? Will now be 1 plus I. That's what it means. So those that become conjugate has a bar on it. It's just like this. When you say conjugate of this answer, it will be 1 minus I, and there is a bar on top. That's how you solve it. So this is minus sign, and this minus will change this minus to what? To plus. That's why we have plus here. Imagine this is plus here. When you put a bar here, it means minus. Minus will change plus to what? To minus. So that is what it means by what? By conjugates. You understand? Let me give another. You have Z is equal to minus 2 plus what? Plus 10i. Very simple. The answer is going to be what? It's going to be minus 2 minus 10i. What you are only changing, you are only changing the sign of the what? Imaginary number. Or you are changing the sign in front of the imaginary number. That's how you find what? The conjugate of a complex number. It's very, very simple. You understand? It's very, very simple. There's nothing hard here. It's just for you to just understand it and you move. You get? So let me give an instance again. Imagine they just gave you a number and they say find the conjugate of Z is equal to 5. How do you find the conjugate of Z is equal to 5? First of all, this 5, this number here can be written as Z is equal to 5 plus 0i, because I does not have a coefficient here. You understand? Did they put any coefficient of I? No. So 5 plus 0i is the same thing as 5. Or you can see 5 minus 0i. Is that clear? So you can just say the conjugate of Z is equal to 5 is also equal to what? Bar Z. That's what it means. You understand? So if you are looking for the conjugate of a number, or if you say find the conjugate of 5, this Z is equal to 5 can also be written as Z is equal to 5 plus 0i or 5 minus 0i. Why? Because 0 times I is what? Is 0. 5 plus 0 is 5. 0 times I is what? Is 0. 5 minus 0 is still what? Is still 5. So what you will get at your Z is the same thing you will get as what? As your bar Z. That is your negative Z. You understand? So it is what? It is reversible. It is vice versa. Do you understand? So that is how you understand the conjugate of the matrix. So when you are studying your manuals, that's for the 100 level, and studying your manuals, you get to conjugate of complex number. That is what you will do. Very, very simple. Not hard to comprehend. As I say, this part is just what is just a walkover part. Is that clear? Is that clear? So there's no much explanation to what conjugate means. I just wanted to just establish something for us to just get to understand. So let me give you some examples now. Let me give you some let me give some example to somebody will grab what I am saying, because I know some people still don't get what I'm saying. But by the grace of God, we are going to comprehend it now. So let's do another example. Another example, they said, look at this. They said, find the conjugate of this number. They say, find the conjugate of each of the following complex number. So the first one is 3 minus 4i. The second one is 2i. The third one is 2 plus I squared. And the fourth one is 1. Or let me just leave this fourth one. I believe somebody should do it so that we can be fast. So let's solve these three questions so we can see what we are saying. So very, very simple. The first answer here, if we want to solve the first answer here, we're going to be getting, remember I said you are only changing the sign of what? Of the, that's the best way I can explain it to you. You are changing the sign of the what in front of the imaginary number. So what are you going to be saying? You're going to say number 1, 3 minus 4i, which is your z, is going to be z is equal to what? 3 minus 4i with a bar on it. So this minus, you change this minus to a plus. So it will be what? 3 plus 4i. This is the conjugate of this number. Is that clear? Is that clear? So the second one, they said, let's find the second one, they said minus 2i. So let z be equal to 0 plus, because we don't have an e, so it should be 0 plus, because our a here is 0. They didn't mention, they didn't put a here, they only put bi, so it's supposed to be 0 plus what? 0 plus 2i. And this is the first part. But if you want now to find the, because remember here it's positive, it shows that there is a plus sign in front. That's how I knew that it is 0 plus. So if you want to find the conjugate of this number, you are going to be changing the sign. It will be 0 minus, or so let's say 0 plus 2i with a bar on it. So what will be the answer? The answer will now be what? 0 minus 2i. So 0 minus 2i is the conjugate of what? Of 2i. So we have found the conjugate of 2i. Is that clear? So minus 2i here, you can see minus 2i is the conjugate of what? Of plus 2i. Do you understand? Minus 2i is the conjugate of what? Of plus 2i. Very, very simple. So for the third one now, the third one is a bit complex. So let me solve it for you now so you can understand the third question. As I said, I'm a bit fast because of our time today. We still have to talk about modules of geometry. We still have to talk about simple operation in metric. We still have to talk about the angered, using the angered rule for metric. So there's still a lot of things we need to talk about. So let's solve this third question. The third question says 2 plus I squared. And why you want to interpret this, you want to interpret this question, is supposed to be z is equal to what? Is equal to 2 squared plus I squared. And remember I told you that whenever you see something like this, it will be what? It will be 2 plus I in bracket 2 minus I. That's what I taught you, right? Remember when we did this rule now. So when you open this bracket, this 2 is opening this bracket, so you are going to be having 2 open bracket 2 minus I, close your bracket. You are going to be having I plus I, open brackets, 2 minus I. So when you open this bracket, you're going to be having 2 times 2 is 4, minus 2 times I is 2I, plus 1 times I is what? Is 2I. I'm coming. Sorry. Sorry, please. I'm coming. Sorry, please. I'm trying to comprehend something. Hmm. Please, this question, I'm coming. I'm trying to see what they did here. If we were to open it like this, please don't mind me. I'm trying to understand this question. Because the way they solve it here is as if they change the sign, then they are not supposed to change a particular sign. So let's look at it properly. Okay, I just understood what they did here. Please, let's just do a random calculation. Please, I'm a bit confused on one aspect. Now, normally when you see 2 plus I, now let's open this bracket. Let's see something. This is complex number, as I said. The way you solve complex number is not the way you solve your normal equation. So you have to be very, 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 very careful. So now let me try something. Now you know that let's just leave it. There is something they did. Now when you open this bracket, normally, what is the coefficient of I here? The coefficient of I here is what? Is 1. Do you understand? And you're having square. So what they did here is that let's separate it and see something. Let's say you're having it. Ideally it's supposed to be like this. Is this not how it's supposed to be? And when we open the bracket, we're going to be having 2 open bracket, 2 plus I, close the bracket, and plus I, open bracket, 2 plus I, close the bracket. So when you open the bracket, imagine what to open our bracket now. So it's supposed to be 2 times I, it's supposed to be 2I plus this 2 times I, it's supposed to be, I'm coming over it first, 2I, you are going to be having I squared. Okay, I understood what they did here. I understood, I'm correct. Now there's something you have to do. Look at it though. This is I squared. That's why I say in complex number you have to be very, very careful. Now remember, in our last class, I forgot something, so I just remembered now. Remember I told you I squared in our last class was what? Was minus 1. Do you remember when I said that? Who can remember? If you can remember, raise your hand. I told you I squared when we're solving that opening of that one that has to be the square. I told you I squared is equal to what? Is equal to minus 1. Do you understand? That's why I say you have to be very, 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 very careful when solving complex number. So we are going to be having 4. We are going to be having 4 plus 2 plus 2I plus 2I is equal to 4I, then minus 1. Is that not so? So when you rearrange, you're going to be having 4 minus 1 plus 4I. And 4 minus 1 is what? Is 3 plus 4I. Since this is, this, so your Z now is equal to 3 plus 4I. Now, when you find the conjugate of Z, when you add a bar on top, so the conjugate will now be what? 3 minus 4I. This is your conjugate. 3 plus 4I, normally Z is supposed to be 3 plus 4I when you open that bracket, and when you find the conjugate, it will be what? 3. I know somebody cancelled it down with my screen, so teacher. So it's supposed to be 3 minus 4I. Is that okay? So that is your answer. 3 minus 4I. Listen, oh, we are not perfect in mathematics. I know you have question, calm down first. We are not perfect in mathematics. That's the truth. We are not perfect. So you have to be very, very careful. That's why, like today, I was very, very busy. I couldn't come down to study the class for today. So that's why. But just because of the knowledge of the last class, we were able to what solve it correctly. So who has any question? All right, let me hear Ene. Let me start with you. Ene, can I hear you? Please keep your hands up in case you have questions so that I'll be seeing you guys. Ene, please unmute your mic. Let me hear you. Ene don't want to talk. Sophia, let me hear you.
So I'm talking now.
All right, let me hear you. You're wasting time.
And I don't understand this part that you open the bracket and I'm seeing 2 outside with 2 plus 1. I don't understand.
I can't hear Ene.
I said, sir,
I didn't hear you.
I said I don't understand this part that you are saying that you wrote two, then open bracket 2 plus 1 after expanding it. I don't understand.
All right, I'll get back to you. Let me hear Sophia. Okay, this guy here, I don't know your name. Is it Francis that is the one that is Sryty? What kind of name is that? Let me hear you, please. Sryty. I can't pronounce it. Though. I'm not the English
Okay,
student.
good evening, sir.
Wait, so
I
what's
don't
your
know
name?
if the first my name is sorry, let me just see the question first. This
Let me hear your name first. If you don't talk, allow me to give
please now,
you.
please, okay. My name is Gideon.
Okay, okay, Gideon. Let me hear
Yes.
you.
Okay. So this 2 plus one
Please,
y
please
raised to power 2. I thought
wait first. Wait,
normally if you want to,
wait first. I'm coming.
okay, I can hear you, sir.
Janelle,
Okay.
Janelle, Janelle, Dennis. Somebody's at the gate. Somebody's open the gate. Yeah, you can speak now. Let me hear you, please.
Okay, thank you. This 2 plus I square. I thought when you wanted to open the bracket or when you want to open the bracket, the other bracket will be the sign will change, like it will be minus sign or something like that.
No, this is not the kind of mathematics we do that. I tried doing that
Okay,
and I didn't continue.
okay, so
Remember
that's
that
the
one?
law. Like when we are solving for it, the signs must be equal.
Yeah, what it means by that square, it means that you are having twice of it. So the sign must be the same, just like twins. You understand? The sign must be the same. You
Okay, sir, thank
understand?
you.
I tried that method, it didn't work. So this is the correct thing to do. So who else has any question before I go back to NN?
Sorry, let me just ask this one before you move on.
Yeah, I can.
Okay, in a situation whereby we have
Hmm?
the sign is minus, are we still going to use that minus twice or we change the sign to?
Yeah, you still use minus minus.
Okay.
Yes. Yeah, thank you. So who else has a question? Please unmute your mic. I can't see your hands up. I want to still go back to NN. Please, if you have a question, can I see your hand before I move? So many people are not in this class today. I won't. It is fair with them. So, Anna, you said your problem is from where again? Please unmute your mic. Let me talk. I don't want to be going back to what I said. As I said, this class is being recorded. So please, in case your problem is for me to go back again, it's not possible. I will tell you go and watch the video. You understand? So I'm just doing this for the last time. Anybody that doesn't understand, don't tell me go back again to another from the beginning. So you want me to explain two questions twice? It's not possible. So this is the last person I'm going to be doing that for. If you don't understand what I teach, you can go and get the video, sit down and watch it like 10 times. It's your business. So for today, this is the last time I'm going back to anything. So let me hear you.
Sir, from this, the third line, I don't know how you expanded it.
It's very, very simple. It's just your secondary school knowledge. What will you do? Remember, in your secondary school, they taught you expression. Is that also they taught you expression under algebra, and they told you that whenever you see two brackets, this first bracket is opening the second bracket. How? This first number is multiplying everything inside. This second one is multiplying everything inside individually. You understand? So when you do this, you are going to be saying 2 times this and I times this. So when you open your bracket now, I believe you know how to open bracket. Is that also board mass? So when you do that, you're going to be having 2 times 2, which is 4, 2 times I, which is 2I times 2I, which is 2I, and I
Yes,
times
I
I is
understand. So just that part.
coming down 2 plus 2I is equals to what? Is equal to 4I. Now remember I told you that if you go and study your manual properly, you are going to realize that I squared is equals to minus 1 because they taught us in complex number. I told you I squared is equals to minus 1, I cubed is equals to minus I bar, is it minus I or I? If you continue like that, I taught you all those things, how to even expand them. I taught them that. So in case I'm still going to do that revision tomorrow, that's on the video. So you get that and watch it and understand how we got I squared is equal to minus 1. So after we did that, you got 4 plus 4I is equal to minus 1. And when you collect like terms, 4 minus 1 is what is 3. This is 3 here. And you bring down your plus 4I. You bring it down. That's how it goes 3 plus what? Plus 4I. And when you find the conjugate of 3 plus 4I, you're going to get what? 3 minus 4I. So that's the answer. Is that clear? Should I proceed? All right. I'm so sorry. I'm so sorry. I muted my mic. I'm so sorry. So as I was saying, this I'm going to be for anybody that's I said a lot and my mic was muted. I said for those who will be having issues and telling me to go back again, please, I won't be doing that. I know, yes, I'm a fast teacher, yes, but I ensure that you understand. That's why I took my time to explain. Please don't tell me that your problem is the come again. That means I should explain one question in 30 minutes. It won't work. That's why I had this class recorded. So if you have issue with this particular topic, go and get the video and watch. That's first. Secondly, I advise, I said for those the only people I'll be focusing on by February, like I'm going to be putting my energy on in the online class, is the JAM students, because I'm going to be having more JAM students by February very, very soon. So with the JAM student, I'm going to be putting more pressure on the online class. For the 100 level, I will advise you, come for physical tutorials. That's one thing that will help you. You understand? Come for physical tutorials. It will help you a lot. So the JAM students um, can be less assured that February is your month by the grace of God. You understand? So, but for the 100 level, I'll still continue with the online class, but it won't be as effective as general class. So that's why I told you not to miss the general class, because a lot will be explained. So the few days that we have, we're going to see how by next week I'm going to go to metrics. I've already treated AP and GP in the physical class, so I will still do a video on it, but I'm not going to be treating that in the online like a live class. No, AP and GP is out of my syllabus for the online class. Is that okay? So let's continue. Now, the next one I'm going to be looking at is representing a geometric. We're going to talking about, you can write geometric representation of a complex number. That one is very, very easy to comprehend. I'm just going to be paraphrasing this and we are out of here. Now, it's just like, remember, how many of you came for the physical class I did? Can I see your hand? If you remember, we were talking about distance, right? And I told you that when calculating distance, there is what we call a plane. I explained a plane for you guys. I told you that a plane has to do with what is a geographical frame that contains or that consists of what two reference points. And I told you the reference point can be what can be x and what and y. And I told you that if you are calculating, for example, if you are calculating for distance, you are going to be having x1, y1, x2, y2. And if you are to represent that on your plane, because this time around we call it the AND guard. When you come to complex number, we call it the AND guard plane. We call it the AND guard plane. So if they ask you to represent something like this on the AND guard plane, it's just the way you represent numbers on your quadratic graph. How do you represent number on your quadratic graph? You are having four axes. You are having your negative axis, your positive x-axis, your negative x-axis, your negative y-axis, and your what? Positive y-axis. This is how you represent it on your angled graph. You call this the angled graph, or you can call it the angled plane. Now, if you are giving numbers, for example, you are giving numbers like 3 and 2, then I give you another number 2 and 3, and they ask you this number on your angled graph or your angled plane. This will be your A, this will be your point B. So imagine you have to represent this. I'm being fast so that you can all comprehend what I'm saying. Do you understand? So that we can move with speed, because this is not where I want to focus my energy on. So this, you will count your number x. This is your x1, this is your y1, this is your x2, this is your what? Y2. So what do? I'm going to be counting 1. What is the highest number in your x? Is 3. I'm going to be counting 1, 2, 3. Let's make it 4. So this is your 1, this is your 2, this is your 3, this is your 4. Then in the y-axis, we are going to, do you have any negative x? No. So I'm going to be having in the y-axis, what's the highest number? 3. So let's make it 4. 1, 2, 3, 4. So you are going to be having your 1, you're going to be having your 2, your 3, and your 4. So now, if you are being asked, I believe everybody can see what I'm doing on the left hand side. So if you are being asked to represent this on your angled graph, you come here. This is your point A. So you come. What is our point A? X1 is 3. So you are going to be having 3. And your X2, your Y1 is what? Is 2. So you plot 3 and 2. So you put this as your A. You now write 3 and 2. This is how your graph will be. You will do it like a dash, 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 dash. The way you plot your quadratic graph, that's how you plot it. Then you now come to x2. What's our x2? 2 and 3. So you come to where 2 is. Y-axis. Your x-axis is 2. Your y-axis is what? Is 3. So you now put point B. You now write the number 2 and what? And 3. So this is how you represent your complex number on your plane, because I told you plane has to do with what? 2 reference points. No matter how many points they give you, they can give you point A to D. You can all represent them on your plane, which we call the angled plane. You can represent it. So they can give you point A, point B, point C, point D. They ask you, represent this on the angled graph. You can do that with ease. Just by the method, I believe all of us know graph and you know how to plot points on the graph. So this is the same way you plot. It's just like your quadratic graph, where you have your x-axis and you have your what? Your y-axis. Or like your simultaneous linear equation graph, rather your linear graph. I said quadratic, it's not quadratic, it's linear graph. It's the same way you plot your linear graph, that you have your x-axis and your y-axis. It's the same way you plot this angled plane graph. That's why we call it the geometric representation of a complex number. You understand? Is that clear? So now, because if you are being given, the reason why I'm giving you this is because normally when you come to complex number, that's the geometric representation. I just gave you this as a what? As an instance. You understand? This is how the point is. But when you go to your manual, you will see that the equation is a bit different, because remember, complex number has to do with what? Has to do with imaginary number. So how does the equation come in a complex number form? So the way it comes is that it will be, let's say, the actual represents 2 plus 3i in a complex number. This 2 plus 3i, this is your x1, this is your y1. That's what it means. So if you want to represent it, if you want to convert this to your point, it's going to be, let's say this is point, this is a, the actual represent this. It's going to be what? It's going to be 2 and 3. This is how you just do it. It's very, very simple. And you now plot this 2 and 3 on your plane. Or if they give you this like this, and let's say they give you another one like 3 plus 2i. It will be what? It will be 3 and 2. You represent it in your plane. The I there is not relevant. Don't worry, the I there is not expired. You're not using it to do anything. So you just throw away the I. Just change it to this, and you can readily plot your graph, or you can readily put down your diagram and do your work, and you are done. That is just how you represent it on the angered graph. So let me give you an assignment under this. Let me give you an assignment under this. So the assignment will be, I'm going to be copying it for you. So I'm going to be copying it now for you. Please do this assignment, snap it, and post it on, I believe, can you guys post, I believe you can submit something on the Google Classroom. So you're going to be snapping it, then you'll be posting it, or you will send it to the MPC class. Yes, send it to the MPC class. Just do the assignment, then snap it and post it on the MPC graph, on the MPC class on WhatsApp. So do that. I believe we are going to succeed in that. So let me give you this one. So they say represents, this is just the equation, represents complex number. I believe everybody can hear me, right? Can everybody hear me? If you can hear me, please raise your hand. Represents complex number 2 plus 3i and minus 2 and minus 3i in the same angered plane. So this is the assignment. Represents these 2 points. So you can name it point P and point Q, or point R and point S, or point, any point you can name it 2 points. So represent this particular digit on your angered plane. That's question 1. Question 2 is for you to represent this number. This is question 1. Question 2, represent these numbers also on the same angered plane. 2 plus 3i minus 2 minus 3i and 2 minus 3i. Represent this one on the same angered plane also. Represents this first number. Yeah, you are going to be having a YouTube. As I said, the class is being recorded. So you are going to be having the YouTube video very soon. In fact, if it is possible, this night you are going to be getting it. This night I'm going to be posting it, and I'll send you a link for you to follow. Just go and watch it there. You are going to be seeing it this night in the on the YouTube channel. So is that okay? So now let's go to the next thing. I believe you have copied this. Who has not copied this? Raise your hand. You have not done copying this. Raise your hand. All right, so let's proceed. So let's look at, this is where I want you to pay attention. The main thing for today's class, we call it the modulus of a complex number. There was a reason why I explained that plane for you guys, that angered plane for you guys. Now we call this the modulus. We call this the modulus of a complex number. Please pay attention. We call this the modulus of a complex number. So what is the formula for the modulus of the complex number? The modulus of the complex number is just simply talking about the distance, calculating the distance in your angered plane. And I told you, I said it's those that came from my physical class, just I think last week and last week. I told you guys that calculating distance, the formula for distance is what? Is just simply s is equals to the square root of your x, let me say your x1 plus your y1 squared. Sorry, your x1 minus your y1 squared. Sorry, your x2, or should I just say the square root of your x squared plus your what? Your y squared. Because when you are finding your distance, you are going to be having 2 points on the x side and 2 points on the y side. So if you have to get your original x side, you are going to be saying x2 minus x1 plus y2 minus y1 all in squared. You are finding their square root. So this is the calculation for distance. So it's the same thing when you come to modulus, the complex number. Please, I'm coming. It is the same thing when you come to modulus of a complex number. The modulus of a complex number, for example, this is how it is represented. Modulus, you see it's just like the way you have determinant of a matrix, like this. These two bar on your z. So the modulus of a complex number is the modulus z is equal to what? The square root of a squared plus what? Plus b squared. This is just the formula for calculating your what? Your modulus. Very, very simple. Remember, you know your a parts. Remember, you know your b parts. Then you just find their square roots and you square them all together is your answer. And also, you must understand that you must also understand that the modulus of z, having your positive z, is equal to the modulus of its conjugate. As I said, this class is just for me to just guide you and give you some details. The modulus of your z, your positive z, or should I say your normal z, is equal to the modulus of its conjugate. Why did I say that? Because imagine your question came, maybe you are solving now, and they ask you for the answer. The answer you will get when solving modulus of z is the same answer you will get when solving modulus of what? Of minus z or negative z. That's what I'm trying to say. Because no matter your digits, no matter, in fact, I'm going to see it in questions now. Because I don't have all these long theory days to discourage me sometimes. You understand? So what we are saying is that the modulus of your z is equal to the modulus of its what? Of its conjugate. Should we proceed with questions? Who is ready for questions here? Can I see your hand? Who is ready for questions here? Only one person is ready. All right, who was the person that wanted to talk? Please, I didn't want distraction. That's why I wanted you not to talk. Please, you ensure, let me finish an explanation before you ask a question. Is it the network that is bad like this? So many people are leaving the class. Is it the network or what? Somebody, please help me find out why are they leaving the class like this? I think network is very, very bad today. For some people, though, network is very, very bad. So is it their network that is bad or what? Please help me find out. You can ask them in the classroom there, what is the problem? Why are they leaving the call like this? Because so many of them are leaving. Is it the network or what? So let's solve some questions here now. Let's solve some questions. So let's look at number one. Let's look at number one. They said find the modulus of z. Example one now. Find the modulus of what? Of z and the conjugate, the modulus conjugate of what? Of z. If z is equal to minus 4 plus 3. Right. So solve this question. They said find the modulus. You see what I'm trying to say now. They say find the modulus of minus 4 of z and the modulus of what? Of the conjugate of z. If z is equal to minus 4 plus 3i, this question is a walkover for you. As long as you know your formula, you are done with this question. You have seen this question, you have seen the answer. What will you do? Remember what is the formula for modulus? Formula of modulus is what? Square root of what? Of a squared plus b.
So where is our a? This is our a. This is our b. So you just come here and say z is equal to what? Square root of what? Of minus 4 squared plus what? Square root of what? Of 3 squared. Remember, we're solving for the modulus of normal z first. We're going to be having z is equal to what? What is 4 squared is what? Is 16 plus 3 squared is what? Is 9. So the square root of 16 plus 9, 16 plus 9 is what? Is 25. And what is the square root for 25 is what? Is 5. That's your answer. So the modulus of z here, when z is minus 4 plus 3i, is what? Is 5. Now let's solve for the conjugate of the modulus of the conjugate of z. Let's solve it and see something. So the modulus of z will be what? Remember, I say you are changing the sign the of the imaginary number side. So we are going to be having conjugate of z is equal to square root of minus 4 squared plus, this plus is a constant. You don't change this plus, please. The only thing you are changing is the second plus here. So it becomes minus 3 squared. Do you understand? This plus is still there. Don't come here and put your plus here. Maybe because you say plus times minus is minus. So you come here and put your minus. No. Put minus 3 squared. Include the minus separately. Leave our addition for us. We did not send you to remove it. You understand? Some people will still go and remove this minus sign because they will say minus times plus is minus. Because you know you need to change this. No. This plus is a formula. So you leave it there. You just write minus 3 squared separately. So you will see that we're going to get another thing. So the conjugate of z is equal to square root of, remember, minus 4 squared is what? Is still 16 plus minus 3 squared is still what? Is still 9. No matter what you do, you will still get the same answer. And what is the answer? 5. So it shows that z is modulus of z is equal to the conjugate, to its conjugate rather. No, I get what you are saying. What I meant is that normally people are normally
just come here and say, okay, since this is a plus sign, I remember I said that when you are finding the conjugate, it will change. Now remember, I told you this addition sign in this formula doesn't change. The only thing that changes is this addition sign here. So when you change this addition sign here, it doesn't affect this positive sign here. This positive sign is still intact here. Look at it here. I'm not seeing the edges of my board. I believe you can. Sorry, the stand is going down. That's a zero. You tell me that it's controlling it. The stand is going down its own. I believe it's okay now. So now, what I mean is that this plus sign here is not changing. This plus sign is not changing. What is changing is this second plus sign I am putting here. Look at it here. So it's changing to minus. So this plus sign is still intact, please. So don't make that mistake to go and change this sign here to minus. Don't change this, please. No matter what you are giving. You understand? So that is what it means by the modulus of a complex number. Just use your formula and you are done with what you are doing. It's as simple as that. Is that clear? So who understand? If you understand this, can I see your hand? This is very, very easy to comprehend. As long as you know your formula, it's very, very easy to comprehend. If you understand, any do not understand, Fatima, any do not understand, Fatima understood. Who else? Please, if you understood this particular part, can I see your hand? Who is that person? So? I want to disturbing somebody this night. Like the person to go home and open. All right, please. So for the person that did not understand, please, as I said, the video will be posted later this night. So please, you can also go and watch it for proper understanding. And I said, I'm planning to trying to be. All right, let me hear you. The person that has the question, please let me hear you. Let me hear you. Please, if you have a question, let me hear you, please. Talk.
Okay, sir, what you did on this left hand side is similar to the one on the right.
Yeah, because it's the same thing.
Okay. About the conjugate, you said this one is the formula for modulus, like calculating the modulus of this complex number. And I understood this one. Then on
My
the
dear,
right hand side, about the conjugate, here earlier you said it's just flipping the signs. So
wait first. My dear,
Sir, I have a question regarding this
please,
sign here.
please, I'll talk. I'll come back to you, please. Thank you. I'll come back to you, my dear. Let me hear Gideon, please. I didn't get your question. It was making noise. Yeah, you can talk now. Gideon network is bad. I can't hear Gideon. Please let him go home, I beg. He's disturbing you. Baba, since almost 30 minutes ago. Gideon, please, can everybody hear me? I'm on my network. Oh. Then, can you hear this guy that is talking? Can you hear him? Because me, I can't hear him. No. Gideon, your network is seriously bad. You have to work on it. Madia, please let me hear you as you work on it. Let me hear Madia, please. I believe Madia can hear me. Is it Madia or please let me hear you if you can hear me, please. Let me hear your question.
Okay, so my question is regarding this sign here.
Which
If
one?
minus 4 plus 3i now, if it was minus instead of plus here, are we going to change the sign when solving for this the modulus of z, not the conjugate, the main z?
Only this one was minus.
Yes.
Yeah, you have to change it also to plus. It's just
No, I understand the conjugate. I'm talking about the conjugate, the main one. You said we are not changing the plus in the formula.
yeah, you are changing this to the formula. So imagine it will still be plus 3.
Okay.
Do you get? Yeah.
Yes, sir.
Okay. Wait. It's not my network. Oh. It's a network. It's not my network. My network is very, very full here. God used to bless me with network. So my network doesn't have issue. I just pray that it continues like that. So I hardly have network issues, seriously. I still want to get another. I'm just using one SIM card, and I thank God that God is helping me. The SIM card is favoring me very, very well. So, any other question? Is Gideon back? Is Gideon back? Let me hear Gideon. Is Gideon back? Rejoice is just enjoying herself. Rejoice, I can see you. You are smiling. And Rejoice, you are smiling just on your bed, enjoying yourself. When me, I'm standing here. And Rejoice. All right, Simi, let me hear you. Simi Joshua.
okay, I want to start. Sorry, sir, can you hear me?
Yeah, I can. Gideon, you're not serious. You're not ready to talk. I'll mute your mic now,
Sorry,
Gideon. I'll
sir.
be in
Can you hear
network.
me? Like I'm speaking, I don't know. Can you hear me? Like you're not responding.
Yeah, I can hear you. Oh my God. Is it my... Yeah, I can hear
Okay,
you. Can
sorry,
everybody
someone
hear?
called me. Like when I immediately I asked the question, someone called me. So
I couldn't hear you. All right, let me hear you.
okay, can you hear me now?
Yeah.
Okay. Immediately I asked the question, someone called me. So I don't know if you can just brief me on the question I asked.
I didn't even hear your question, sir. How will I now brief you? No worry, when you remember the question, let's not waste time. When you remember the question, you can
Just
come back.
forget about it. The network is very bad. I will ask you during physical classes.
Yeah, when you come for physical
I
class,
will
you can
ask you
just,
during
if I'm
physical
free.
classes. The network is very bad.
Yeah, that's what I said. That's what I said. See me, let me hear you, please. Please, you can mute your mic back. See me.
Okay, you said the conjugate of a complex number is the inverse of the complex number.
Yeah.
You're not changing the
Yeah.
sign, you're just using the same sign. Why are you not changing it? Did you get me?
Yeah, I got you.
Okay.
Yeah, is the inverse. Is the inverse of the complex number. For example, I just explained that to you. I said conjugate means inverse. You understand? So when you solve for inverse, when you are only changing the sign of the sign in front of the complex number. In front means in front of bi. So imagine you are having plus in front of bi. When you are finding the conjugate, it's going to be minus. Imagine you are having minus in front of bi. When you are finding the conjugate, it will be plus. As simple as that. That's what it means. Exactly. All right. So any other question? And then let me hear you. Hey, and I is confused. Let me hear you. Let me hear you.
So, so I don't understand this part. This one that you put -3 in bracket.
This one
Yes, yes.
is the
I
conjugate.
thought it
Remember
was
in
the whole it was the whole this plus sign that is supposed to change.
you are not changing. Remember what I said. It is your formula sign, so you can't change it. What you are only changing is the sign in front of your question. This is your formula. So this you are still retaining this addition sign here. What you are only changing is what is the sign in your what in your question. This addition you are seeing here did not just appear. It was gotten from what from our formula. Is that okay? So you are not changing it. The only one you are changing is the one that comes from the question. So that is how why this is what minus. Because remember in our question they say find the conjugate. And I just mentioned here that the conjugate is the inverse of that complex number. Is that okay? All right, thank God you have understood. So any other question as we proceed? Any other question? All right, so let's look at the next thing on our which will be the last that we're going to be looking at. And the last part we're going to be looking at is what we call the okay, let me just give you this rule. The quality of a complex number, look at this. Let me clean this on the board. I want to ensure that I touch every part for you guys this night. We are still not done with complex number, but I'm going to be finishing it in our next class on Wednesday. So please don't miss the Wednesday class by the grace of God. If there's a class you shouldn't miss, it's this Wednesday class. If you miss this Wednesday class, physical class, I believe everybody has resumed now. I don't know what you are still doing at home. They have not resumed. I believe everybody has resumed. Hey, some people are still eating meat in the house. Okay. Now, when we talk about equality of two complex number, equality of two complex number, what I'm trying to say, the rule is just saying that if you have two complex number like a plus bi is equals to c plus di, what if you want to find the equality of these two complex numbers? A must be equal to c and b must be equal to what? D. For these two complex number to be what? To be equal, which is equal to 0. What it means is that when finding because why I'm giving you this rule is because when we get to addition, that's your simple operation in your complex number, you're going to be applying this rule. What they are saying is that for you to get an equal complex number, you must ensure that what is on this A side is the same thing as what is on the C side after the equal sign. And what is on this BI side must be equal to what? DI. So your A is equal to C and your B is equal to what? Is equal to D in order to get a what? An equal complex number. So for two complex numbers to be equal, A must be equal to C, B must be equal to D. As simple as that. Example 1. Let's solve an example. Like I said, I'm just trying to be as fast as I can. Example 1. They said here, they said for what value of x, I don't want to copy the equation, but this is the equation. They say for what value of x and y, and this is the equation for x and y. For what value of x and y, you have 5x plus 6y and 10 plus 18i are equal. You see, for what value of, sorry, there is I here. For what value of x and y is what? 5x plus 6y and 10 plus 18i are equal. What they are saying is that for what value must x be in this equation is equal to 10 plus 18i. So what must be the value of x and y for this equation to be equal, or for this complex number to be equal? So x is a number, y is a number. So what must x be and what must y be in order to get what? This value here. So what do? You just can remember I said that you are picking this complex number and what by this complex number. So it's going to be 5x. So you are picking this number and this number. 5x is equal to what? 0. Remember, this is your A, this is your C, and I told you A must be equal to C. So if you want to get the value of x, what do? Divide both sides by 5, divide both sides by 5. 5 cancel 5, x is equal to what? 2. So x must be 2 in order to get what? 10, because 5 times 2 is what? Is 10. Very simple. So 6y I is equal to 18i. So what do? Divide both sides by what? 6i, divide both sides by 6i. 6i we cancel 6i, y is equal to what? This will cancel this, y is equal to what? 3. So y must be 3 in order for what? For your equation or for your complex numbers to be what? To be equal, because 6 times 3 will give us 18 on this side, on the left hand side, and 5 times x is equal to what? 10. And I told you A must be equal to C and B must be equal to what? To D. This is your A, this is your B, this is your C, this is your D. In order to get an equal complex number. I believe this is clear. Francis wanted to talk. All right, you don't want to talk. Should we go to the next thing?
Sir, I want to talk. Sorry.
Let me hear you.
Okay, you get tired of me. Sorry. This iota now. When you were canceling this, to get the value of y, this iota, you also cancel it. So.
I cancel the iota.
I said yes. Like, are we going to cancel like? And the iota will not be there when giving the final answer, right?
Is it I you are looking for? What are you looking for?
No, I'm just asking so I'll be sure in case of exam or test.
Me too, I'm asking in case of you
now
are
you
confused.
say to indicate that this number is an imaginary stuff like that. So you have to do I. Sorry.
I'm asking you a question. What are you looking for? Is it I or Y? What are you looking for?
Sorry, sir, I understand now. Thank you.
You did not answer my question. This guy will soon permanently close your mic. Someone will take note of this guy. If you want to talk again, mute his mic. So this is why you say I'll get tired of it, okay? Maybe to mute your mic. Yeah, I'm just joking. If you have any question, please, you guys. I love the fact that you are asking questions. It shows that you are really, really following. You see, a student that doesn't ask questions is probably some of you haven't watching television in your house now. You just muted your mic.
Since you are still in your parent house, so it seems that some of you are watching the world. I mean, let's continue. You did not see you rejoice there. Rejoice is just balance, low key. Just imagine that maybe chicken is even moving in the mouth there now. Nobody knows. Just smiling at us. And rejoice. Maybe chicken is low key or she's eating it. Mute her mic. Now if you mute the mic now, she's cracking bone. Big one, cracking it, tearing the bone marrow, everything. God will help us. So let's just look at this last part, then we are done for this class. Is that okay? I believe somebody understood this mathematics part. If you know you understood everything I said from the beginning till now, can I see your hand? If you understood everything I've been talking about from the beginning till now, can I see your hand? All right, that's good. That's a good response. This is not a good response. If you understood everything I've been saying from the beginning and your network did not cease, Monday did not understand. Monday, see me in our next class, in our physical class in case you are coming. So let me know your problem, please. So I believe everybody understood. At least those people that will not understand should be a handful. They shouldn't be much like that. So let's look at addition of complex number. Let's look at addition of complex number. We are still going to come. So from our next class, we are going to continue from subtraction. So let's just talk about the addition of complex number. So example, if you are given a complex number like, if, follow me please, if z1, because in addition you are having two complex numbers. So if z1 is equal to a plus bi and z2 is equal to c plus di, then they are two complex numbers. Remember, they are two complex numbers. Then what will be their sum? What will z1 plus z2 be? What will it be? So in order to find z1 plus z2, you are going to be saying a plus c. That means you are bringing the normal number, the real numbers together. There's going to be plus b plus d. We bring the complex number together in brackets, then I outside. What I mean is that this is the formula you use when solving an addition problem in complex number. What you will do is that your A is adding to this C, to the second complex number. That means the real number in the first complex number is adding up to the second real number, to the second number in the second real number in the second equation or in the second expression, like A plus C. Then the one, the imaginary number, will be what? Will be B plus D, imaginary number outside D. Is that clear? So just understand the formula. Understand your formula and you are done. Understand your formula and you are done. So let's just solve one question, then I give an assignment to take and go and eat as breakfast tomorrow morning. Is that okay?
So look at this complex number first. Example 1 now. Okay, let me clean this. I believe somebody have copied this. So let me clean this. Please just follow this class. Once you understand what I am teaching here, you'll become 10 times better than your mates. Let me tell you the truth. Once you understand what I'm teaching here in this class, because what you are doing is that you are gaining free access to your manual. You understand? You are gaining free access to your manual. So once you open your manual now, you are scattering everything inside. You can solve any question just with this little knowledge I've given you. So you are privileged to be in this class. That's the truth. It's not, as I said, some people think, it's the money I paid. It's not the money you paid. It's the privilege you have. You understand? So they said calculate 3 plus 2i plus, now you see what I'm saying, 4 minus 3i. This is the first question. They say solve this. 3 plus 2i plus what? 4 minus 3i. Are you following? So what do you do? From our formula, you have gotten your answer. What do you do? First of all, You remember what I said? I said that in this case, you are going to be adding this and this and this and this. Is that okay? So what do? You are going to be having your answer will now be what? Your answer is going to be that's going to be what? 3 plus what? Plus 4 plus 2 minus what? Minus 3 I. And what will be our answer? Our answer will now be what? 7 plus, okay, before we add now, 2 minus 3 is what? Minus 1. Is that not so? And minus 1 times I is what? Is minus I. And minus times plus is what? Is minus. So it's going to be 7 minus I. This is the answer. As simple as that. I repeat. Very, very simple. 3 plus 4, 7. 2 minus 3 minus 1 times your I minus I. Plus times minus is what? Is minus. So it becomes minus I. So your answer here is what? 7 minus I. Addition of metric of complex number is very, 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 very easy to understand. Very, very, very easy to understand. Look at another question. They said solve this one now. Now let's look at this question. They said, I believe somebody, okay, look at this question now. Somebody should solve this one. 2 plus 5I plus 3, sorry, minus 3 minus 7I plus, open brackets, 1 minus I. So this is your question. 2 plus 5I plus minus 3 minus 7I plus 1 minus I. So to solve this question now and give me the answer. You have 30 seconds for that. Solve this question. 1 minus I. That's what is on the last side. NEPA should bring lights now. What you can do furnace is this? Oh. Is that, are you done? What's the answer? Please, you can send it in the income message. I didn't see anything. What's the answer? Can somebody tell me his or her answer? What's the answer, please? What is the answer? We are rounding up now, please. What is the answer, please? Minus 3I. Who else with another different answer? Who else with minus 2I? All right. Who else? Who else with a different answer? Minus 3I minus 3I. I. All right. So I've seen enough. So the answer is minus 3I. That is the answer for question 2. Minus 3I, 0 minus 3I, because it's very, very simple. You just come here and say 2 plus minus 3 minus 1. 2 minus 3 is what? 2 plus minus 3, then plus 1. So you are going to be having minus 1. Minus 1 plus 1 is 0. Is that not so? Because 2 minus 3 is minus 1. Minus 1 plus 1 is what? Is 0. We are done here. We are going to be having 5 plus minus 7. So 5 minus 7 is minus 2. Minus 2 minus 1 is what? Minus 3. So it will be minus 3i. Simple arithmetic, just simple addition you are doing here. There's no big deal here. So in our next class, we are going to be looking at the subtraction of the complex number. From there, we'll look at addition, multiplication, and division of complex number. And with that, we will call it a complex number. So in our next class, we're going to be seeing how we can go far in our question. You didn't get it, Ene? Yeah, didn't you understand? This is as easy
That
as
this part, I don't understand where the 3 is coming from. Cause me, I got 2.
how will you get to look at this? Remember, the part with the I are adding themselves. Is that not so? So you are going to be having minus 5 minus plus, sorry, minus, you are having plus 5 plus or minus 7 because you're having minus 7, right? Plus 1, look at what I'm doing here. Plus 1, look at it. So plus times minus is what? Is 5 minus 3 plus 1. So 5 minus 3 is what? Sorry, 5 minus 7 rather. 5 minus 7 plus 1. So 5 minus 7 is what? Minus 2. Is that okay? Sorry, this is minus I. I say plus 1. This is supposed to be minus I. So it's supposed to be plus minus I rather, sorry. So since you know this is minus I is minus 1. Is that not so? So it's going to be minus 1 because there is a 1 behind it. That's what you did not put. There is a 1 behind this I. That's what you did not put. So you are going to be saying minus 1. So it will be minus 7 minus what? Minus 1. 5 minus 7 minus 1. So 5 minus 7 is minus 2. Minus 2 minus 1 is what? Minus 3. That's how you got minus 3i. Because you did not include, you don't know that behind every letter there is an invisible one. Did they tell you? So there was the one behind that idea. That's why you did not get it. So that's how you got your minus. So where did you throw away the one?
So why did you not put the 1 again?
Eh?
The I. Why did you still put the I?
There is I behind here too. All of them they're in brackets. Your I is what is multiplying everything inside. You understand?
Okay. Yes, sir.
Yes. So that's what you are doing there. It's not magic. Is that clear? All right. So without any question, all the announcements will be sent to the. We have a lot of announcements for you guys. So all the announcements will be sent to the class. Make sure you listen to everything I'm going to be saying this night. So ensure that you do what is right. If you want to keep on learning in this platform, you must ensure that you obey every rule we give. Please obey everything we say. Once you obey, you will follow us back to back, and you will see that you are growing. You understand? We are after your growth. We are after your growth. We want to ensure that every student in this platform is growing. You are different from other people outside there, so you must ensure that you follow us every step we take. As you can see now, our video is being recorded. For somebody that is wise, will go and watch the video and understand. And if he doesn't understand, he will also go and watch it again. You can watch this video more than 5 times just for you to understand. If you're a slow learner, this is an opportunity for you to pick up fast. There is a room. There is room for everybody to pick up. See, let me tell you the truth. Let me not call anybody the but the least among us here has the ability to get a first class. It's just that you have not yet unleashed the ability yet. If only you can understand that you have the ability to do that, then you will see that it becomes simple for you. You understand? So there's no those people who are getting first class, there's no magic behind it. It's just hard work and discipline and working smart. So I believe with these little words of mine, you are convinced that you can do it. You don't also you can do it. Everybody can do it. So just follow everything we are doing on this platform, and you will realize that you are changing and you are becoming somebody better. So did somebody learn anything from this class today? Can I see your hand? If you learned something from this class, can I see your hand? All right. So everything about the physical class is going to be sent, will be posted on the group later when our physical class will take place, the timing, the location, and the rest. So good night, everyone. Have a good night rest.